1, 2, 1, 2. Hello, can people hear me? Ah, perfect. Okay, so today's topic is inequalities. So I'm going to talk about maths, and I will demonstrate to you which I believe the most powerful method of solving inequalities. You might be familiar with it. It's called the method of intervals. Have you heard about the method of intervals for inequalities? Method of intervals for inequalities. Have you heard? Yes or no? Please let me know in the chat. Only for modulus. You could use it for modulus, yeah. Oh, I don't have any modulus questions prepared for you today, but we can do that next times. Okay, so the method of interval. So let's, this is pretty much the topic of today's session. I'm going to share my screen. Oh, it is sharing. Okay, so method of intervals. Okay, so I'll just write that down. Method of intervals. Method of intervals. Now, the method of intervals is so easy to use that this inequality that you see in front of you, problem 1, can be solved by, well, I don't know, a trained monkey. Because the method of intervals is so simple, okay? And it's so simple to use. And for some bizarre reason, it's not taught in school. I don't know. So you will see what I mean. So let's see, what do we have here? We have a fraction consisting of 3 different pieces, 3 binomials. X plus 3, 5 minus x, and 2x minus 5. Basically, we have a multiplied by b divided by c, which is greater than 0. Okay. Well, we could potentially look through all the possibilities. So A, B, and C. A, B, and C can be positive, negative, positive or negative. So A could be or 0, of course. If A could be positive, B is positive, C is positive. So in this case, the whole fraction is what? Positive, negative. Positive, yeah. If A, B, and C are positive, the whole fraction is positive. If A is positive, B is positive, C is negative, it's going to be negative, right? Easy. If positive, negative, positive, it's going to be negative. If it's positive, negative, negative, it's going to be positive. And then we have negative, positive, positive, and that would be negative. Negative, positive, negative is going to be positive. Negative, negative, positive is going to be positive. And if A is negative, B is negative, and C is negative, it's going to be negative. It's not easy. It's not the easiest way to do that, of course. But that's the idea. Does everyone understand what the table means? Is everyone on board? If not, please let me know. So what I've done is I've taken this fraction and I'm saying, well, it looks like this one, very similar. And so, yeah. And here, when I figure out when they are positive, okay. I'm not going to do that. This is not easy, and it's not very informative. But what I want to know is when are they positive and when are they negative? And I clearly see that x plus 3 is positive if x is greater than minus 3, and negative if x is less than minus 3, right? The first term is positive if x is greater than minus 3, because any number greater than minus 3 won't give you a positive result. Similarly, 5 minus x is positive if x is less than 5, and negative if x is greater than 5. Yeah. And the last term, so 2x minus 5 is positive if x is greater than 5 over 2, and negative if x is less than 5 over 2. So the bottom line is something interesting happens only at these 3 points, minus 3, 5, and 2. And these are known as the critical points. Critical points. So all I need to do, so method of intervals. It has 3 steps. First, find the critical points. Critical points. 2, determine the sign on each interval. And 3, choose the intervals, the needed intervals. Okay. So how does that work? I found the critical points. So step 1, I found the critical points. First, the critical points are minus 3, 5, and 5 over 2. So this is the points where something happens. Either the numerator or the denominator turns to 0. 2, determine the sign on each interval. So what to do, I draw a line and I put the critical points, minus 3, 5 over 2, and 5, 3. Determine sign on each interval. Sorry, I need to determine the sign. So if x is greater than 5, so we're looking only at 4 intervals, 1, 2, 3, 4, 4 different intervals. If we are in the interval from 5 to infinity, so if we're in this interval, here, all 3, on this interval, at interval, let's call it interval 1. Interval 1. X plus 3 is going to be positive. 5 minus x is going to be negative. And 2x minus 5 is going to be, positive. So negative, positive, negative, positive. So that's a minus, that's negative. I'm going to draw it as minus. And I'm going to draw it here, underneath. Now at 5, I know at 5, this bracket, 5 minus x, changes sign. And if this changes sign. The whole fraction changes sign. So it's going to be positive. At 5/2, it changes sign again. It becomes negative. And at -3, it becomes positive again. And so the function, the fraction, looks like this. Positive. It's positive from -infinity to 3. So we need the positive ones because we need greater than 0. So we're looking for the positive ones. So we shade them. And we say that x belongs to the interval from -infinity to -3, union from 5/2, I like to say or from 5/2 to 5. And that is the answer. So x is less than -3, or it is between 5/2 and 5. Easy? Not easy. Let me know in the chat. Easy or not easy? Or rather, do you understand it or not? Doesn't matter. Interval or set notation, whichever method you like. You know, it doesn't. -infinity is not a real number, therefore you can't include it. So let me show you how this can be done really quickly. I'll take another one. I'll take another similar problem, maybe slightly more. So problem, I'll call it problem 1a. 1a. So x multiplied by x minus 2, x plus 4, divided by x plus 1, x minus 7. And let it be less than 0. So find the critical points. I don't even need to write this down. All I need is to draw a line. X. I've put the critical points. The critical points are 0 here, 2. So where each of these turns to 0, -4, -1, and 7. And now just put them on the number line. So that's -4, -1, 0, 2, 7. And now let's work our magic. Above 7, if x is, let's suppose x is 100. So something really large. X is 100. So if x is 100, this is positive, 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 positive. So all of them are positive. And that means that the whole fraction is positive. If x is between 2 and 7, everything except this one is positive. Therefore, the whole fraction is negative. Between 0 and 2, this is negative, this is negative. Therefore, the whole thing is positive, negative, positive, negative. So typically, that is what you see. The signs alternate, and then you just draw a squiggly line. And then shade the regions that are negative, so less than 0. So bam, 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 bam. Bam, 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 bam. And then just write down the answer. X is from -infinity to -4, from -1 to 0, and from 2 to 7. So it takes you about 35 seconds to do. Okay. The squiggly line is the hardest part. Is that making sense? Do you understand the method? Please let me know. Maybe on a scale of 0 to 10. Let's do on a scale of 0 to 10. Do you understand? How many people today? Okay, 10 people. Where I'm expecting 10 tens. So that's 8 tens. 2 people are being shy. That's 9. And 1 more. Okay. Right. There are certain additional rules which I'm going to demonstrate. But effectively, at every critical point, the function changes sign. At every critical point, the function changes sign. By the way, it would be helpful to see what it looks like. Perhaps. So let's see if I can do that. Okay, so that. That demos, if I do y is equal to fraction x minus 2 x plus 4 and then x plus 1 bracket x minus 7. Okay. So, and as you can see, how does that work? So the function changes sign at -4, changes sign at 0, changes sign at 1. Did I make a mistake? Yeah, I think I did. I made a mistake. Oh no. A 2. Okay, that's a 2. Sorry, that's 2 minus 1. It changes sign at -1, at 2, and at 7. It doesn't. You don't necessarily notice that it changes sign at 7, but it does. Look, if you draw a asymptote, because 7 is an vertical asymptote, it does change sign, because to the left of 7 it is negative, to the right of 7 it's positive. And the same for -1. To the left of -1 is positive, to the right of -1 is negative. So you can see that. So this is where the signs changes. So this is not a realistic representation of the graph, but it does show you the signs of the function, whether it's above the x-axis or below the x-axis. And okay, so that's that. Okay, so here there are a few things that are new to us. The first new thing is less than or equal. So we need to learn how to deal with that. And also we see squares and cubes and 5 and quarters. Right, so, but the method, the basics of the method stays as it is. So find the critical points, 0, 9 over 2, that's 4.5. 1, -4, and 3. So these are the critical points. We draw a line. We put the critical points on the line. But now, if the point is a solution, we need to include it. If the point is not a solution, so if a point is included, it's like this, included, and circle is not included. So we know that we can't have a 0 in the denominator. So x is not equal to -4 and x is not equal to 3. So -4 is going to be a dot like this. 3 is going to be a dot like this. But the other points are included. So 0, 0, 1, and 4.5. 4.5. So these are the critical points. Now, if x is 100, so take something ridiculously large. If x is 100, you can see that this is positive, 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 positive. So all of them are positive. So we start with a plus on the right. Now at 4.5, well, at 4.5, you can see that this bracket does change sign. So it becomes negative. At 3, where is 3? 3, but 3 is to the power of 4. So it changes sign 4 times. So it becomes positive, negative, positive, negative, positive, positive, negative, positive, negative. So it becomes negative again. So it doesn't change sign at 3 because it changes sign 4 times. So forward, backwards, forward, backwards. All right. Then at 1, it changes sign 3 times. So overall, it does change sign, becomes positive at 1. At 0, it changes sign twice. So it doesn't change. So it becomes positive again. And at -4, it changes sign again. So it's negative. So bottom line is odd power, change of sign. So odd power, change sign. Even power, don't change. And that makes sense. Like x squared doesn't change sign at 0, right? X squared stays positive, right? Always stay positive. All right, and now we draw, and now the squiggly line is going to be slightly more advanced. When you have a dot, a solid dot, you draw a square like this. And when you see a round dot, it's a circle. So it's like this. And then once again, it goes down, right? Square, then positive, square. Now here, it goes down and then up again, square. Because it touches, so obviously there's touching at 0. And then it goes like this. Okay, and we need the negative ones. So we need the negative or 0. So we 0 included. 0 is a solution. 0. So the solution is x belongs to from -infinity to -4. Then the point 0, a single point, because it can be 0, because at 0, the whole thing is 0. Then from 1 including to 3, not including, and from 3 not including to 4.5. There are different ways, 4.5 including. So different ways of writing this down, but I don't mind which way you use. Okay. I think this is the easiest way. But you could use set notation. You could use, yeah, whichever method you like. And yeah, how well do you understand this problem on a scale of 0 to 10, please? One, two, three. 1, 2, 3, 4, 5, 6. Only 6 of you? 5, 7, sorry. 7. Okay. All right, let's move on. But this is the idea. Basically, okay. When you see something like that, for 0, well, it's not an interval, right? It's a single point. So it's x is between minus infinity and minus 4, or x is 0, or it is 0, or it is between 1 and 3, or it is between 3 and 4.5. So it's a set containing, this is all points between minus infinity and minus 4. This is just 0. Just 0. Okay, because it can be 0. It can't be anything on the interval from minus 4 to 1. It can't be anything other than 0. All right. If you see something like this, don't be alarmed. It doesn't look like the previous one, but we can make it look like the previous one. So all we need to do is to modify it. So 1 divided by x squared minus 5x plus 6 minus 1/2 is less than or equal to 0. So we multiply this by 2. We multiply this by x squared minus 5x plus 6. There's going to be 2 minus x squared plus 5x minus 6 divided by 2, open bracket, x squared minus 5x plus 6 less than or equal to 0. So I found a common denominator, and I've written it as a single fraction. Now all I need is to simplify it. So it's going to be minus x squared plus 5x plus 4. 2, I can factorize that. So x minus 2, x minus 3, less than or equal to 0. Can I factorize this? I can. I can take minus out. It's going to be x squared minus 5x minus 4. Is that factorized? Does that even? That doesn't make any sense. It's not plus 4, it's minus 4. Okay. So here it's going to be plus 4. Okay, that makes more sense. And this is 2, x minus 2, x minus 3, less than or equal to 0. There's going to be minus x minus 1, x minus 4 divided by 2, x minus 2, x minus 3, less than or equal to 0. So the critical points are 1, 4, 2, 3. And now I draw them. 1, 2, 3, 4. So 1 including, 2 not including because it's on the denominator, 3 not including because it's in the denominator, and 4 including because it's in the numerator and it can equal to 0. Because if the numerator is 0, the whole thing is 0 and it's equal to 0. And then I choose, so if x is ridiculously large, something like 100, so positive, 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 but there's a minus, which makes the whole thing negative. And then there are no special cases here. They all just change the sign like good boys and girls. And then we just draw. And we choose the negative ones, which is the ones that are negative. So bam, 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 bam. And then we just write down the answer. X belongs to from minus infinity to minus 1, including. The infinity is never included because it's not a real number. And from 2 to 3. And or from 4 to plus infinity, not including, then that's it. So it all boils down to getting your inequality to look like this, like a fraction with a 0 on the right. Once you've done that, everything else is smooth sailing. All right. Now this one. This one doesn't look like the previous one, but we can still use elements of that. We just need to do some extra steps, perhaps. First of all, we notice that because there's a square root of x, you cannot have a square root of a negative number. Therefore, there's a limitation. X is greater or equal to 0. Of course, x is not equal to 2, but we already know how to deal with that. We already know that what we can do. But then everything else is the same. We have the critical point here. So what is the critical point for the top? What is the critical point for the numerator? 9, very good. 9, and the denominator, the critical point is 2. That's what you do. X, and then you have 0. You can put 0 now, or you can put it later on, but I prefer to put it right away. So 0, because x has to be greater than 0. And then 2, not including, and 9, not including. We can safely say that this is positive, negative, positive, and who cares what that is, because that doesn't exist. Okay, so positive, negative, positive, bam. And we stop here because we have to. So we choose the positive ones. So the solution is x belongs to from 0 to 2 and from 9 to plus infinity. I keep using semicolon, but in Britain, you normally use a comma. It's not a big deal. Any questions? In the previous one, of course. Why would I need to do that? Oh, you mean in the beginning? Yeah, I could. Yeah, of course. That would probably be easier. You're right. At the end, I could have multiplied it by -1, but that involves changing the sign. And people usually forget to change the sign when they're multiplying by -1. So I recommend not dividing or multiplying by negative numbers, just to be on the safe side. Because if you get rid of this minus, you have to change that sign. And people usually forget to do that. Okay. Now, the next few problems are not solved using the interval method. They are solved analytically, or you could do them graphically, by the way. You can always solve an inequality graphically. So, okay, what do we see? Inequalities is also sort of art, if you wish. So first of all, the thing on the left is a square root. The square root, that means you cannot take you cannot take sorry, you cannot take a square root of a negative number. Therefore, x has to be greater or equal -61. That's your limitation. Secondly, this is a square root, and we know that square roots are always greater or equal to 0. And the right-hand side is greater than that. Therefore, the right-hand side is also greater than 0. So x has to be greater than -5. I don't know if we're going to use that, but we can write that down. X has to be greater than -5. Yeah, does everyone understand? So the left-hand side is non-negative. And the right side, it has to be greater than that positive number. Therefore, x plus 5 has to be greater than 0 as well. And therefore, x has to be greater than -5. Okay. Then the only other thing, because because the smallest value that this can be is 0, and this is greater than that. And so it has to be greater than -5, not equal. Sorry, -5. Okay. Now, once we have the limitations in place, now you can see that this limitation is not needed because we already have this limitation. So this is redundant, right? Because if x is greater than -5, of course it is greater than -61. But we can square it because we know that both sides are positive. Both sides are positive. So we can square it. Square both sides. Right? There are situations where you're not allowed to square both sides. Let's see. Let's say -4 is certainly less than 2. Okay? But if you square both sides, you get 16 less than 4, which is nonsense. Okay? 16. So that's just wrong. Okay? So you can only square an inequality if both sides are positive. Right, I hope that makes sense. Now, Bella, that's an excellent question, but square roots are not negative in the way we define the square root. So when we take the function, the square root is a function, and the domain of this function is x is greater or equal to 0, and the range of this function is y is greater or equal to 0, right? It cannot be negative, because if it could be negative, then we would be in trouble, because that would not be a function anymore. It would be it would look like this. And that is a problem, because for a single value of x, we have two different values of y. So it's not a yeah, it's not it's not a function, because it's a one-to-many mapping. And if you take Desmos, like, hello, Mr. Desmos, and you say y is equal to square root of x, and you can see clearly it can only take positive values. So square root is only positive, because that's how we define the square root. There is another definition, like that you have to rewrite a whole big chunks of maths in order to accommodate for that. But no, we don't do that. We just say square root is positive by definition. Okay, so both sides are positive, so we can square both sides. And that means x plus 61 less than or x squared plus 20 plus 10, x plus 25, and x squared plus 9x minus 25, 61. It's too late in the day for me to do that in my head. And it's greater than 0, right? Because I'm kind of moving that to this side. And then I can factorize it. So it's going to be x 36, that's 12 and 3, I believe, plus 12, x minus 3, greater than 0. Have I made a mistake? No? Don't think so. Minus 36, 12 minus 3 is 9. Yeah, that is correct. And now you can use the interval method of intervals. So that is minus 12. And that's minus 3. Oh, sorry, 3. And we see that it is positive, negative, positive. But then we have a limitation. X is greater than minus 5. So we have to include that. Minus 5. We have to disregard everything up to minus 5. And yeah, that's how we do it. We need the positive ones. So oh, okay. We only need the positive one, so it's the answer. X is greater than 3. That's the solution. Or if you like it fancy, x belongs to from 3 to plus infinity. Okay. We can't take the left-hand side because we have a limitation. that making sense? All right, this one. This one is trickier because now it has several things to consider. First of all, what if, so first limitation is x has to be greater or equal to 2, because you cannot take a square root of a negative number. Limitation 1. Now, you want to square it because that's what you want to do. You're not allowed to square it until you make sure they're both positive. So you need to see, what if they're not positive? Well, if this one is negative, it's definitely going to be less than the square root because the square root is always positive. So if this is negative, then this is also always true. So if x is less than 3, x is less than 3 is a solution. Well, of course, considering 2. Because if this thing is negative, it's going to definitely less than that. That's the solution. If x is greater than 3, well, actually, we can consider if x is equal to 3, what happens? If x is equal to 3, this is 0, and this is 1, is also a solution. If x is 3, what am I doing? Oh, apologies. X equals 3 is also part of the solution, because we've substituted, and you see that goes 0 less than 1, which is true, because 3 minus 3 is less than 3 minus 2. If x is greater than 3, then both left-hand side and right-hand side are positive. So now we are allowed to square it. Okay? Do you see the logic? Do you see how I'm approaching this problem? So I want to square it, but before I square it, I have to look into the nitty-gritty details. You're only allowed to square if they're both positive, so that's what I'm doing. And it's going to be x squared minus 6x plus 9 less than x minus 2. X squared minus 7x plus 11 less than 0. I'm assuming I can factor that. X. Can I factor that? Well, I can, but it's not the easiest factorization. It's going to be x minus 7 plus square root of 5 over 2, and x minus 7 minus square root of 5 over 2, less than 0. And then I just do that. 7. This is 7 minus square root of 5 over 2. 7 plus square root of 5 over 2. Now I need to place 3 as well. So where is 3? So 7 minus square root of 5 over 2, that's 2.38. So 3 is here. Yeah, so 3 is in between. So that's, we're only allowed to do this. So positive, negative, positive. So it's going to be this, but we need less than 0. So it's going to be this bit. So x belongs from 3 from 3 to 7 plus square root of 5 over 2 is also a solution. So finally, we can combine and write down the answer. From 2 to 3, 3 and this. So we can stick them together. So the answer is x belongs to from 2. I'm just going to write it 3, 3, and from 3 to 7 plus square root of 5 over 2, right? But I mean, if it's up to 3, 3 and from 3, that means we can stick together, or we can stick the intervals together, and 2 to 7 plus root 5 over 2, not including. And that's the solution. Okay. Any questions? Any questions? Okay, 7. This is coming back to 7 is coming back to the method intervals, pretty much. I'm gonna make it simpler. I'm gonna write this out as 3 to the power minus x minus 8 minus 3 to the power 4 divided by x. Well, I can factor that, I believe. Can I? I don't think I can factor that. Oh yeah, I can't. So x squared plus 2x plus 1 plus 4. I can complete the square here and show that 3 minus x minus 8 minus 3 to the power 4 divided by x plus 1 squared plus 4. Now, this thing, the bottom thing, is always positive. Always positive. Positive. Therefore, the whole thing is equivalent to 3 minus x minus 8 minus 3 to the power 4 less than 0. And that's easy. So that means 3 to the power minus x minus 8 is less than 3 to the power 4. And because 3 is an increasing function, 3 to the power x is a increasing function. That means minus x minus 8 less than 4. And that means x is greater than minus 12. That's the solution. That's quite cool. I didn't expect that answer. So what I'm doing here, I'm saying that this bottom thing, you don't have to complete the square. You just need to acknowledge that this expression is always positive. So it's as if you're dividing by a positive number. And the question is, when is this thing negative? Well, this thing is negative only when 8 plus x minus 81 is negative. So that means 1/3 to the power 8 minus plus x has to be less than 81. So 1/3, so that means that 8 plus x has to be greater than minus 4. X has to be greater than minus 12. Is that making sense? Is that? Do you understand what I've done here? So the denominator, if it was less than or equal, that would be greater than equal to minus 12. Oh. Oh, yes. Sorry, Rakav. The question for this one. Yes, we would have included it. Yes. Because it's allowed to be. Okay. Now, problem 8. So problem 8, we have x to the power of. Now, we assume that this is an exponential function. Exponential function. An exponential function is only defined when x is greater than 0. Because you cannot have minus 2 to the power 2/3, for example. Oh, no, sorry, you can have 2/3, but you can't have minus 2 to the power, I don't know, 1/2. Yeah, not possible. So when we say a to the power x, we always say that a is greater than 0. Actually, we also say that a is not equal to 1, but I mean, a could be 1 potentially. That would be a very boring function though. Okay. Now, with exponential functions, if the base is greater than 1, then if a is greater than 1, then a to the power x greater to the than a to the power y means x is greater than y. If a is less than 1 but greater than 0, then a to the power x greater than a to the power y means that x is less than y. And that makes sense because, I mean, if you have if you have 1/3, for example, if you have a number less than 1 to the power of something, the bigger the power, the smaller the number. And if the base is more than 1, then the bigger the number, the bigger the power, the bigger the number. All right, so if, and yeah, so what do we need to do? So case 1, x is greater than 1, then x to the power 2x minus 1, 3 minus x, greater than 1 is x to the power 0. X to the power 0 means 2x minus 1 divided by 3 minus x is greater than 0. And you can use the interval method here. So 1/2, 3. And also x is greater than 1. So that's your limitation, 1. And it's positive, negative, positive. And we need the positive one. So x belongs from 3 to plus infinity is a solution. Case 2. X is between 1 and 0. Then x to our 2x minus 1 divided by 3 minus x greater than x to the power 0 means 2x minus 1. 3 minus x is less than 0. It's the same picture. 1/2, 3, except there's a 1 here. It's a, and we need a negative 1. So x belongs from 1/2 to 1 is a solution. And we just need to figure out what to do with 1. Oh, if x is 1, if x is 1, this is 1 to the power 1 over 2. So it's 1 to the power half, which is 1. And this is not greater than 1. So 1 is not a solution. And so the answer is from 1/2 to 1 and from 3 to plus infinity. That's the solution. I made a mistake somewhere. Of course I have. Sorry. It's, yeah, I messed up. I messed up both sides, by the way. And here. Because it's, when x is large, this is 2x minus 1 is positive, this one is negative. So we start with a negative, positive, negative. So it's like this. And we need the negative side. So it's from but we also have a limitation that x has to be greater than 0. So 0. From 0 to 1/2. 0, 1 to 1/2. And here we have negative, positive, negative. So it's like this. And it is from, it has to be greater than 1. So it's from 3, because it's from positive. So it's from 1 to 3. 1 to 3. So it's from 0 to 1/2 and from 1 to 3. Okay. The last one. So for logs, it's the same logic because it's log 1/3 and 0. So this is going to be log 1/3 of log 1/2 of x plus 4 over 2x minus 3. And it's going to be less than log 1/2, 1/3, 1, right? Because 0 is logarithm of 1. And we can remove the logs, but because the base of the log is less than 1, we have to change the sign. Sign changes as the base is less than 1. Therefore, we have log 1/2 x plus 4 2x minus 3 greater than 1. And 1 can be expressed as log 1/2, 1/2. And then again, the base is less than 1, so the sign changes again. So it's going to be x plus 4 by 2x minus 3 less than 1/2. And then you can solve this using the interval method. So this is x plus 4 minus 2x minus 3, 2, 8, and 2x minus 3 less than 0. 2x, multiply this by 2. Yeah, multiply it by 2x minus 3. Why do you change signs when comparing, not dividing? What do you mean, sorry, comparing? You are taking logs. Look, if you have 3 is greater than 1, then log 3 is greater than log 1. But if you have 3 is greater than 1, then log 1/3 3 and log 1/3 1, it's going to be the opposite, because the base is, if this is 3, for example. The sign changes because the base of the log is less than 1. And yeah, so, and then we just use this standard method. So 2x, oh, 2x cancels, interesting. So it's going to be 5 over 2x minus 3 less than 0. So that's a single critical point, 3 over 2. And now, do we have any limitations? Yes, we do have a limitation. The fraction itself cannot be negative because you can't take a log of a negative number. So, and x plus 4 divided by 2x minus 3 has to be greater than 0. All right, so this has to be negative and this has to be positive. So here's positive, negative, that's easy. So we're interested in the negative part. And this part, so we have minus 4 and 3 over 2. So positive, negative, positive. We're interested in the positive. So the only place where both inequalities are satisfied, that means it is from minus infinity to minus 4. Both satisfied. When? I hope you understand where this one comes from, because you can't take a log of a negative number, therefore this fraction has to be positive. So we solved the whole thing to get this, but also we need to keep in mind that x plus 4 divided by 2x minus 3 has to be positive. Okay, and that's a limitation. Okay, I'll finish here. I hope it was useful. I hope you understood the method. Don't worry if you didn't fully grasp problem 7 and onwards. But I really hope you've managed to get the method. So yeah. And see you everyone next week. Welcome.